Hello students, welcome to the part 3 video of chapter 9 differential equations. So in this video we'll be continuing with the 3-mark questions of the differential equations chapter which came in 2024 and the 2 case-based questions which came in the 2 years, my dears. In 2 specific regions they ask case-based questions and you can very clearly see, like I said in the previous video, it will be based on the 3-mark questions only. Okay, so let's next question, my dears. Find the general solution of. We have seen the same question in 2023. I put it back here again so that you will understand that it's the same one, but it's not the same question. It's the same type of question. Do you see that if I put lambda here, it becomes lambda squared x squared plus lambda squared y squared by 2 lambda squared xy. Lambda squared cancels off. So you still get back the function without the lambda, so it's homogeneous. But in the 2023 paper, it was the reciprocal form, where xy was in the numerator. So I told you flip it. Here don't flip, because in that case, numerator was just 1 term and in denominator it was 2 terms. Now it's numerator 2 terms, so don't flip it. So we'll just go for the substitution. It is HDE type 1, which says y is equal to Vx implies dy by dx is equal to v plus x. Please memorize the substitutions at least, my dears. It's very easy to memorize these substitutions. So that implies v plus x into dv by dx is equal to x squared plus v squared x squared by 2x vx. I told you the substitutions are done to make the right side in form of the function v only. No x, x will cancel off. So we'll see what's happening here. V plus x dv by dx is equal to x squared into 1 plus v squared by x squared into 2v. Cancel off x squared both sides. That implies v plus or x into dv by dx is equal to 1 plus v squared by 2v minus v. You just take LCM, you will get x into dv by dx is equal to 1 plus v squared minus 2v squared divided by 2v. 1 plus v squared minus 2v squared. That implies x into dv by dx is equal to 1 minus v squared divided by 2v. So now right side it's purely simplified as a function of v. Now we are ready for the simplification. So we can write it as 2v by v squared minus 1 dv equals minus dx by x. I just did one small smart step where I took the minus common from this to make it v squared minus v, and I left the minus on the right side itself. Now integrating both sides. Now do you see that this is again substitution? T is equal to v squared minus 1 implies the derivative is equal to 2v dv. Perfect derivative. That is why I left the negative sign on the right side itself and I brought the pure function to the left side. Now I can rewrite the integration as integral of dt divided by t is equal to minus dx, because I have a habit of leaving the unwanted constants and signs on the right side. Okay, so answer is going to be log t is equal to minus log x plus log c. Okay, so log property, I can see log t is going to be log of v squared minus 1 is equal to log of c by x. So we can say v squared, log cancels off. We can say v squared as, v squared is going to be y squared by x squared. So y squared by x squared minus 1 is equal to c by x. Just take LCM both sides. You will get this as y squared minus x squared is equal to cx. Y squared minus x squared is equal to cx, my dears. Again, it's the same type which we did before, but the same question when we did with homogeneous type 1, see how difficult it looks. But the previous question, if you had done in the same way with type 1, it would have looked difficult like this. But now it's easier if you just flip it over there. So please, that's what I'm telling you. You can still do it. Type 1, type 2 homogeneous, both are same, but you can still do it. But there's a difficulty coming in the integration part and the solution part if you don't recognize the correct type. Okay, that's all, my dears. Okay, next question, my dears. Solve the differential equation. Do you see this function now very, very clearly? It's not going to be homogeneous if you try to put lambda for this term over here. Lambda y, that lambda is not going to go anywhere. It's going to stay there only. So it's not homogeneous. So let's try linear differential. Linear differential says I'm made up of all x functions with a single y, or I'm made up of all y functions with a single x. Look at it. I am made up of all y functions. I am made up of all y functions with a single x. For the first time for 2023 and 2024, they have asked us a question in the form of LDE type 2. They did not ask even a single question of LDE type 2 in 2023. But in 2024, a question has come. And LDE type 2 says the differential equation should be dx by dy plus r into y is equal r into x. We have seen this form already in the MCQ discussion, my dears. MCQ discussion, they had asked LDE type 2. Okay, but for 3 marks, it's the first question. Dx by dy. So I need dx by dy. So I don't have any dx by dy here. So I'll divide dy everywhere. So I'll get my expression as tan inverse y minus x is equal to 1 plus y squared into dx by dy. Now dx by dy says I should have an x term with me. So take that x term there. So it'll be 1 plus y squared into dx by dy plus x equals tan inverse y. I just took this negative x, that's why it became positive x. So now dx by dy should be having coefficient 1. We have seen this kind of question already before. Dx by dy should have coefficient 1. So if you divide with 1 plus y squared throughout, divide 1 plus y squared throughout the equation, my dears. Divide 1 plus y squared throughout the equation, you will get the expression as dx by dy plus 1 by 1 plus y squared into x is equal to tan inverse of y by 1 plus y squared. Now you can simply compare the original LDE type 2 form and you can say that implies expression is ready. So comparison says r is a function of y and s is also a function of y. So it's going to be a correct equation now for the LDE type 2. And what's the integrating factor for this? Integral of e raised to integral of r. R is a function of y, so r dy. E raised to 1 by 1 plus y squared dy, which is equal to e raised to direct integration. I told you, direct integration or substitution. 1 by 1 plus y squared integral is tan inverse y. So e raised to tan inverse y. Now what's the formula for the solution of LDE type 2? Solution of LDE type 2. The formula, my dears. Okay, the formula is x into integrating factor. Before it was y into integrating factor. This time it is x into, because that was single y. So y into integrating factor. This is single x. So x into integrating factor is equal to integral s into integrating factor. But your functions are in terms of y. So dot dy. Substitute the answer, my dears, of the integrating factor. X into e raised to tan inverse y is equal to integral s tan inverse y by 1 plus y squared into e raised to tan inverse y dy. Again reminding you, symbol substitutions or direct integration. Very clear. This is substitution over here. So I'll call now t is equal to tan inverse y. And the derivative dt is equal to 1 by 1 plus y squared dy. Perfect substitution. dy by 1 plus y squared is going to be dt. So my answer is ready for integration, that is x into e raised to tan inverse y is equal to integral t into e raised to t dt. This is an integration which we have already done before. Integration by parts. Algebra t comes before exponential e raised to t. Integration by parts. You can write the answer as x into e raised to tan inverse y. T integral e raised to t minus whole integral derivative of t into integral e raised to t whole dt. Correct? Now put back the result. X into e raised to tan inverse y t e raised to t. Derivative of t is 1. Integral of e raised to t is e raised to t. Again integral of e raised to t, e raised to t plus c. Yes? You've done this already. That's why derivative of t is 1. Integral of e raised to t is e raised to t. Again integral of e raised to t becomes again e raised to t. Now put back t, my dears. T is equal to tan inverse y. So the final answer is x into e raised to tan inverse y equals tan inverse y into e raised to tan inverse y minus e raised to tan inverse y plus c. Answer over. So this is the final answer, my dears. I hope everybody is clear with this question. Yes, a similar type question came in 2023 also. Very similar question. Okay, but we had to just rearrange it to get to that form. That's all. In 2023, we got a form like this. But in 2024, they made you to rearrange it into an LDE type 2. It was to type 1 in 2023. You can watch the previous video, you can understand that. Yes. Next question, my dears. Find the particular solution of the differential equation given by. Okay. So look at this equation, my dears. Do you see that it can be written as a homogeneous form? Because I can see this is going to be 2 lambda squared xy plus lambda squared y squared minus 2 lambda squared x squared dy by dx equals 2. So equals 0, my dears. Equals 0. I can see lambda squared common. It will come out and eliminate with the 0. Got. So it is very clearly HDE type 1. You don't have to show this. In the exam, nobody is asking you to show it. Until unless they say, show that it's homogeneous, don't do this. Okay? Show it's homogeneous means you put that. Okay, let x is equal to lambda x, y is equal to lambda y, and show it to them. But for a 3-mark question, showing and then doing is too difficult for a question. Okay, so they will not ask you to show it. You can do it in the rough work and check. Okay, now if you should understand this homogeneous type 1, you would always rearrange it as 2xy plus y squared is equal to 2x squared. I told you we need dy by dx alone on one side. So divide with 2x squared, all of you. So dy by dx is equal to 2xy divided by 2x squared plus y squared divided by 2x squared. So you will get dy by dx is equal to y by x plus y by x squared with a 1 by 2. 1 by 2 y by x squared. All of you, let's go for a substitution. Let y is equal to vx. dy by dx is equal to v plus x dv by dx. Substitute because it is HDE type 1. Just substituting directly. So v plus x dv by dx is equal to v plus half v squared. Okay, so I can take out v on both sides. Okay, so my answer is going to be dv by v squared is equal to half dx by x. I told you, leave unwanted constants on the right side itself. So now we're going to integrate it. Okay, so it's going to be minus 1 by v is equal to half log x plus c. Minus 1 by v is equal to, so put back v is equal to y by x. So 1 by v is equal to x by y. So minus x by y is equal to half log x plus c. Put back x and y, my dears. X is 1, y is 2. X is 1, x is equal to 1, comma y is equal to 2 implies minus 1 by 2 equals 1 by 2 log 1 plus c. Log 1 is a 0. So half log 1 is also 0. So c is equal to minus half. C is equal to minus half. I got my arbitrary constant C as minus half. Now I'm ready for my particular solution, my dears. My particular solution is minus x by y is equal to half log x minus half. Half log x minus half. I can take 2 this side and I can write it as minus 2x is equal to y log x minus y. Y multiplied is 2 multiplied this side. Again, if you want a small rearrangement again, you can write it as final answer. I'm just writing it over here. It's going to be 2x plus y log x minus y equals to 0. It's not compulsory. If you leave it like that, also nobody is going to take your marks. I just want it to look it more beautiful. Okay, that's all. So I can write it as equal to y. That's also a correct way to write equal to y. So y is equal to 2x plus y log x. Y is equal to 2x plus y log x. Your choice, my dear. The way you write the final answer is your choice. Perfectly your choice. Nobody is going to take your marks. They will only check whether you did the integration correctly to get the result and whether the arbitrary constant is correct. Only these two things they will check. Once that is right, they will give you full mark. Okay? Next, my dears. Find the general solution of. Find the general solution of. Is it homogeneous? Let's see. Okay, this is lambda y dx. This is lambda x plus 2 lambda squared y squared. Lambda squared. That lambda is not going. My dears, it's not homogeneous. Perfect. Once it's not homogeneous, check for what? Linear. Check for what? Linear. So it's not homogeneous. Forget about it. Now check for linear. What does linear say? I should be all x term with a single y. Let's check. All x term. No, there are more. Only one x term here. I should be all y term. Check. I should be all y term. Check this. Y term with a single x alone, my dears. Yes, a perfect LDE. A perfect LDE type 2. See, 2024, the second question coming in LDE type 2. 3-mark question. LDE type 2 says you should write it as dx by dy plus r into x is equal to s. I need dx by dy plus r into x. So let's see, I will divide with dy everywhere. So I will get my equation as y into dx by dy. Dividing dy everywhere. X plus 2y squared. Now I need the x term this side. So y into dx by dy minus x is equal to 2y squared, and dx by dy should be alone in LD. LD dx by dy type 2 should be alone. So divide with y. Divide y throughout. Divide y throughout, my dears. What happens if you divide y throughout? You will get dx by dy minus 1 by y x equals 2y squared by y, which is 2y. Now I have a perfect form, my dears. So from this I can conclude that r is equal to minus 1 by y. Just compare. Compare, my dears. R is equal to minus 1 by y. S is equal to 2y. Form ready? Formula for integrating factor. E raised to integral r dy. E raised to integral minus 1 by y dy. That is equal to e raised to minus 1 by y is log y. Again, coefficient of the log goes as a power. So is equal to e raised to log. We have done n number of questions like this in the MCQ part. So many times a similar question has come for MCQ for finding the integrating factor alone. Check that video, part 1, my dears. Very important. So y raised to minus 1 is your answer. So your integrating factor is y raised to minus 1. What is integrating factor, my dears? Y raised to, which is 1 by y. Yes. So solution, please. Solution of LDE type 2. Solution of LDE type 2. X into integrating factor equals integral S into integrating factor. X into y raised to minus 1 is equal to integral s is 2y. 2y into y raised to minus 1. Yes, so x by y is equal to integral 2 dy. Y and y raised to minus 1 will cancel off. Yes, that is equal to 2y plus c. Only general solution. Beautiful question. X is equal to 2y squared plus cy. Answer over. Very, very simple 3-mark question for the board exam. I hope everybody is clear. Yes, my dears? Yes? Okay, next question. Only identification is difficult. You see that, right? Once identification is done, question is easy. Come on, look at it again. dy by dx is no doubt variable separable already in the product of y and x term. Look at it, it's a product of y and x term directly. It's variable separable. Don't try to do anything else. So you can write it as dy by y is equal to cot 2x into dx. Don't try to spoil it by thinking any method, a direct VSM form. How simple. It's a normal 1-mark question, my dears. They're asking for 3 marks. That is equal to log y is equal to integral of cot x log sine x. My dears, it's not x, it's 2x. So the derivative of 2x is 2 plus log c, my dears, because both sides are log. Yes, so that implies log y is equal to half. The coefficient of log is half. Okay, so half goes as a power log of sine 2x raised to half plus log c. My dears, half is the coefficient of log. So that goes to the power of the term inside the log. Now log a plus log b. So log y is equal to log a into b. Yes. Take out log on both sides. What's going to be the answer for y? Y is equal to c into sine 2x whole raised to half. So I am done with the general solution of the differential equation. They want particular solution. Let it be. Now they're giving you the values, so no issues. So x is given, y is given. So x is equal to pi by 4, y is equal to 2. Substitute x is pi by 4 and y is equal to 2. So y, that is going to be substituted. You get 2 is equal to c into sine pi by 2 raised to half. 2x, x is pi by 4, so 2x is pi by 2, no doubt. If x is pi by 4, 2x is pi by 2. Sine pi by 2 is 1, 1 raised to half is 1, so definitely c is equal to 2. Sine 90 is 1, 1 raised to anything is 1, yes, so sine 1 raised to half is 1, so c is equal to 2. So my particular solution is, therefore, solution is y is equal to 2 into root of sine 2x. Because sine 2x raised to half is square root of sine 2x. So 2 into root of sine 2x. I hope everybody is clear with this. Yes. Okay. Moving on to next question, my dears. Now, next question is, find the particular solution of the differential equation. Again, do you see y by x form, my dears? Already given to you in the previous video that if you see y by x, if you see a function of y by x, no doubt it is going to be a homogeneous type 1. And homogeneous type 1 says dy by dx is equal to f by g. Yes, I should write it in the form of f by g. Now all of you, I need dy by dx. So it's going to be x into dy by dx is equal to x into e raised to y by x plus y. Okay, now I will divide x everywhere. So dy by dx is equal to e raised to y by x plus y by x. Homogeneous type 1. So my substitutions are, let y is equal to v by vx and dy by dx is equal to v plus x dv by dx. Okay, substitute, my dears. So we will get v plus x dv by dx is equal to e raised to v plus v. V again cancels. I think it was the same question that came in 2023. 2023 was the same question came without a change. Only some slight modification in the equation. That's all. Same question came. dv by e raised to v is equal to dx by x. Okay, that's going to be e raised to minus v dv integral is equal to dx by x. Here they're asking you to find the particular solution also. That's the only thing I think is different here. E raised to minus v by minus 1 is equal to log x plus c. So minus e raised to minus y by x is equal to log x plus c. Can you please substitute y as 1 and x as 1? Y is equal to 1, comma, x is equal to 1. If y and x are 1, so answer is going to be e raised to minus 1. Okay, minus e raised to minus 1 is equal to log 1 plus c. Log 1 is 0. E raised to minus 1 is 1 by e. So c is equal to minus 1 by e. C is equal to, only the difference in that question, they did not ask you particular solution. Here they're asking you the particular solution, but the equation also, I think it was x into dy by dx over there. Okay, so it's going to be a direct substitution for c. C is equal to minus 1 by e. Put it back in the solution, my dears. Answer is minus e raised to minus y by x is equal to log x minus 1 by e. Okay, that is the answer, my dears. Don't try to do so much rearrangement and spoil your answer. Okay, I don't like that kind of a logic always. Just leave it like this. Whatever you get, leave it as an answer. Particular solution. Done, my dears. Okay, next question, my dears. All of you, find the particular solution of the differential equation. dy by dx minus 2xy, my dears, not going to waste too much time. All x with a single y. All x with a single y, LDE type 1, which says my differential equation must look like dy by dx plus py. It's a perfect match. No need to rearrange. Perfect match, my dears. That implies if you match it, p is equal to minus 2x and q is equal to 3x squared e raised to x squared. Answer done. Now formula for integrating factor of LDE type 1, e raised to integral pdx. P is minus 2x. So that is equal to e raised to integral minus 2x, which is equal to e raised to minus x squared. Because it is minus 2x squared by 2, 2 cancels off, minus x squared. So solution of the differential equation is y into integrating factor equals integral q into integrating factor dot dx. So y into e raised to negative x squared. Y into e raised to negative x squared is equal to integral q 3x squared e raised to x squared e raised to negative x squared. Now you can cancel these two. They are reciprocals of each other, my dears. E raised to x squared, e raised to negative x squared. Reciprocals, cancel them off. Y into e raised to negative x squared. 3x cubed by 3 plus c. Solution done. My general solution is e raised to negative x squared is equal to x cubed plus c. Okay, this is my general solution. But they're asking for the particular solution, my dears. So how do we find particular solution? Just substitute the values of x and y. So very clearly what is given inside the bracket is x and what is given outside the bracket is y. So x is equal to 0. Y is equal to 5. So I'm just going to put x as 0 and y is equal to 5. So my equation is going to be 5 e raised to 0 is equal to 0 plus c. That implies c is equal to 5 because e raised to 0 is 1. The value of the arbitrary constant is 5, my dears. I hope everybody got the way of substitution. Please, there are certain students I've seen over the years that simple values of x and y they substitute but still make the arbitrary constant wrong. Please don't do that. It's simple values only. Do it very slowly and carefully. Perfect 3 mark is needed from this answer, my dears. Okay. So what is my answer then, my dears? Answer is y into e raised to negative x squared is equal to x cubed plus 5. Answer over. Final answer. So y into e raised to negative x squared is equal to x cubed plus 5. This is the particular solution of the differential equation, my dears. I hope it's clear to all of you. Yes. Moving on to the next question, my dears. The next question is, solve the following differential equation. Obvious, homogeneous. It's homogeneous, my dears. Like for example, if you take the y inside, it's yx and y squared. All of them will have a lambda squared. So it is homogeneous, my dears. I have no doubt. Okay, it's homogeneous. And homogeneous needs what form, my dears? dy by dx. dy by dx is equal to f by g. Let's try to make dy by dx here. So you're going to divide dx everywhere. So x squared into dy by dx plus yx plus y squared equals to 0. I just multiply y inside. Now dy by dx into x squared is equal to negative of yx plus y squared. I took this whole bracket to the right side. Okay. Now I'll divide with x squared, all of you. dy by dx is equal to minus yx by x squared plus y squared by x squared. So dy by dx is equal to minus y by x plus y by x the whole square. Okay, now it looks y by x homogeneous, no doubt. Substitute LDE type 1, let y is equal to vx. dy by dx is equal to v plus x dv by dx. Those who are still having a doubt on why it's homogeneous, please put x as lambda x, y as lambda y. You will see again the lambdas get eliminated. Okay, so the substitution is done. So v plus x dv by dx equals minus v squared. Yes, if this v goes that side, it becomes x into dv by dx is equal to minus 2v minus v squared. Now I can take the minus common out and leave the denominator as v squared plus 2v is equal to minus dx by x. Now do you see again, this is a direct integration form, my dears. It's 1 by quadratic. You have to complete the square. All of you, it's a direct integration method. Okay, it looks 1 by quadratic, which you have to do it using the method of completing the square. I'll complete the square on the right side for you. So you should rewrite it as v plus v squared plus 2ab minus 1 squared, sorry, plus 1 squared minus 1 squared, my dears. So it's going to be a squared plus 2ab plus b squared minus b squared. There is no b squared there, so I created minus b squared there. That is equal to v plus 1 the whole squared minus 1 squared. Yes, v plus 1, the completing the square form is done. All of you. So that is going to be written as integral of 1 by v plus 1 squared minus 1 squared. Completing the square, once again I'm telling you, calls for a plus b whole square or a minus b whole square. Here it is plus, so I'm using a plus b whole square logic. What is a plus b whole squared? You should rewrite it as a squared plus 2ab plus b squared. A squared plus 2ab. B is 1 here because there's 2 there. 2ab is 1. Yes, plus b squared is not there, so I put a plus b squared and a minus b squared. No other term there. Is equal to minus dx by x. Now, my dears, what is the formula for 1 by x squared minus a squared? 1 by x squared minus a squared is 1 by 2a log mod x minus a by x plus a equals minus log x plus log c. Okay, half goes as a power. So log of mod v by v plus 2 raised to half is equal to log of c by x. Log cancels. Now please put v. V is equal to y by x. So if you put v is equal to y by x, you will get y by y plus 2x raised to half is equal to c by x. Okay, because it is v is y by x, so this is also y by x. LCM x will cancel off, so it becomes y plus 2x in the denominator, the whole raised to half. Log cancel on both sides, answer is equal to c by x. There is no particular solution, only general solution here. So I think this part is very clear to everybody. Yes. Next question, my dears. Find the general solution of the differential equation. Look at it, my dears, it's not homogeneous anyway. It's not homogeneous. Why? Because log x, you put lambda there, lambda is not going to come out. Okay, now let's see, is it linear differential? Yes, it's linear differential because I see it's made up of all x terms with a single y. Correct? So it is LDE, my dears, LDE type 1, which can be written in the form dy by dx plus py equals q. Once again, all x functions with a single y, or all y functions with a single x. So I need dy by dx, so dividing dx everywhere. So y minus x into dy by dx plus x log x equals 0. So I'll take this terms that side. So x into dy by dx minus y is equal to x log x. I just simply took the dy by dx terms that side so that I want the dy by dx term positive. But I need the coefficient to be 1 as well. So I'll divide x everywhere. I'll divide x everywhere. So dy by dx minus 1 by x y equals log x. Now very simple comparison. You can say that implies p is equal to minus 1 by x. Q is equal to log x. Now what is my integrating factor? My integrating factor is equal to e raised to integral p dx. E raised to integral minus 1 by x dx, which is equal to e raised to minus log x. E raised to log x raised to minus 1. Answer is x raised to minus 1, which is 1 by x. I got the integrating factor, my dears. So based on that solution is y into integrating factor is equal to integral q into integrating factor. Yes, y into integrating factor. So y into 1 by x. Q is log x. Log x into 1 by x. My dears, basic substitution. Log x is t, 1 by x is dt. Yes, basic substitution, my dears. T is equal to log x. So derivative t is equal to 1 by x dx. Put it back in the integral, my dears. Answer is going to be y by x is equal to integral t dt. So y by x is equal to t squared by 2 plus c. Put back t, my dears. T is equal to log x. So y by x is equal to log x squared by 2 plus c. Answer over. Very simple again, my dears. Just identification is the only part you should be very careful about. Otherwise, these kind of questions are very, very easy for us. Yes, I hope this is clear. Yes, my dears. Next question, my dears. Again, you can see it's not going to be homogeneous. Definitely not homogeneous because log x, e raised to x, lambda is not going to come out from that. Okay, got it? You try substituting. Don't believe this what I'm saying. You just try substituting in the exam. Exam, you must substitute and check. Don't simply check, okay, lambda is not going to come out. Oh, don't think like that. Just put and check always. It doesn't take more than 30 seconds or something like that. Okay. Now, is it a linear differential? No, it's made up of so many terms of x and y. Cos y is not a single y. So it's basically variable separable form. And what does variable separable form say to us? You should be able to write as a function of x into a function of y, or a function of x divided by a function of y. So can I write this as dy by dx is equal to x into e raised to x log x plus e raised to x divided by x into cos y. It is definitely variable separable. It's pure x term divided by x into y term. It's a pure integration, my dears. So cos y dy is equal to integral of x into e raised to x log x plus e raised to x divided by x dx. Okay. Now, integral of cos y is very simple, so I'll do it. Wait. And I can see that e raised to x is common here. I'm just taking it out. I will get x log x divided by x plus 1 divided by x dx. X cancels off. So integral of cos y dy is equal to e raised to x into log x plus 1 by x dx. Direct integration form in chapter 7, my dears. I hope everybody remembers this property of integration. E raised to x f of x plus f dash of x is always a result e raised to x f of x. This is a direct property of indefinite integrals. It can be applied in any integration form. If you see that the integration looks like e raised to x f of x plus f dash of x, log x derivative is 1 by x, then directly you can write the result, my dears. So what is the integral of cos y? Sin y. And what is the integral of e raised to x f of x plus f dash of x? E raised to x f of x plus c. This is the general solution. I use that result over there. Please write that result in the exam before you apply it and put the values of x and y. All of you, what are the values of x and y? If x is equal to 1, y is equal to pi by 2. You substitute that, so you get sin pi by 2 is equal to, substitute x equal to 1. So log 1 is 0 plus c. So c is equal to sin pi by 2 is 1. I got the value of the arbitrary constant, my dears. C is equal to 1. So that implies, substitute, my dears, sin y is equal to e raised to x log x plus 1. Answer ready, my dears. This is, see, I told you, a promise is always a promise, that the integration part of a differential equation is always going to be a basic level. Okay, my dears, I hope it's clear. Next question, my dears. Again, this is variable separable, my dears. Let's do it directly. dy divided by y into log y is equal to x into log x dx. Integrated both sides. Okay, all of you, a very, very simple method. Now, this can be done using the method of substitution. T is equal to log y. So, dt is equal to 1 by y dy. So, the left side is going to be dt by t. Right side, my dears, it is not direct substitution. It's integration by parts. Logarithm function, my dears, you are going to call it as u. An algebraic function, you're going to call it as v. Direct integration by parts. Integration by parts, my dears, u into integral of v minus whole integral of derivative of u into integral of v whole dx. Okay, so 1 by t log t, x squared by 2 log x into 1 by x into x squared by 2 dx. X and x squared get cancels off here directly. So answer, put back t, my dears. Log t, log y equals x squared by 2 log x minus half integral of x squared by 2 plus c. There is only general solution. So your answer, you can write it one step if you want to. Log y equals x squared by 2 log x minus x squared by 4 plus c. Answer done. General solution of the differential equation. I hope that this video is very clear to everybody regarding the 3-mark questions. Now, like I said, there are 2 questions which came for case-based in this particular chapter, differential equations. Only one question in each year. Very simple, you will see it's very, very simple, my dears. So let me show you the question one by one. Section 4-mark question, my dears. The first case, you can read it. An equation of involving the derivatives of the dependent variable with respect to the independent variable is called a differential equation. And if you can represent the function is said to be homogeneous, if you can write it as x is equal to lambda x, y is equal to lambda y, the lambda comes out, and if it eliminates itself, that means this n is going to become, all of you, if it eliminates itself means this is going to become lambda raised to 0. Otherwise, it will not eliminate. To solve a homogeneous differential of the type, okay, I think there's a mistake in this question. It's not dy by dx with a root. This root is not there. Just remove the root, okay. This root is not there in the question. dy by dx equal to f of xy is equal to g of y by x. Didn't I say that g of y by x could represent homogeneous type 1? We make the substitution y is equal to vx and then separate the variables. Whatever theory I have been saying till now is described over here for homogeneous. Substitute x as lambda x, y as lambda y, and you will see that lambda comes out and lambda eliminates. Eliminates means the power of lambda is going to be 0. Based on the above, answer the following questions. Show that it's a differential equation of the type. So I to show it like that, so I need dy by dx. So x squared. Question number 1, my dears, x squared minus y squared into dx plus 2xy dy is equal to 0. I'm just taking this term that side and dividing with the dx. 2xy dy by dx is equal to y squared minus x squared. I just took it that side, so it became y squared minus x squared and dy by dx. So what is dy by dx? Is equal to y squared minus x squared by 2xy. And I must show it like a function of y by x. Split the numerator. That implies dy by dx is equal to y squared by 2xy minus x squared by 2xy. That is going to be dy by dx is equal to y by, or I can say it as half common out y by x minus x by y. I just took half out, y by x minus x by y. So finally, one more step I can show. Dy by dx is equal to half into y by x minus 1 by y by x, x by y. See, I have expressed it in the form of y by x. That's what they're saying. Show it like a function of y by x. Answer over. First answer done, my dears. Normally, we don't do this for homogeneous. Once we realize it is homogeneous, we directly go for substitution. Okay? You can do this to show it's y by x. So, type 1 is always y by x functions and type 2 is always x by y functions. Okay, now solve and find its general solution. So, when you go to solve it, my dears, you can see that substitution is going to be, already they have given to you, y is equal to vx and dy by dx is equal to v plus x dv by dx. So from that we can substitute on the left side, v plus x dv by dx is equal to half into, I said y by x, right? Y by x is v. Y by x is v. So can I write it as half into v minus 1 by v. Check. V minus 1 by v. Okay. All of you, I can now take v that side. So x into dv by dx is equal to half v minus 1 by 2v minus v. Okay. Now we are going to take the LCM here, my dears. Otherwise, I cannot separate it on both sides. Okay. LCM is going to be 2v. And LCM is going to be 2v, right? So it's going to be v squared minus 1 minus 2v. This is going to be v squared minus 1 minus 2v squared. Okay. Minus 2v squared. Now it's going to be x into dv by dx is equal to minus v squared plus 1 by 2v. Done. Minus v squared plus 1 by 2v. Now I can separate it on both sides. Separate simply, my dears. So you're going to get 2v by v squared plus 1 dv is equal to dx by x. Integrate. This question we have already done before. A similar type we have already done before. Substituting v squared plus 1 as t, the derivative is 2v, my dears. So substitute, my dears. T is equal to v squared plus 1. The derivative of t is 2v dv. Similar type, that's why I'm just simply writing it and going. So answer is going to be integral dt by t. Integral dx by x. So it's a simplification, my dears. I'm just putting back and taking LCM and then rearranging. So the first idea was to write it in the form of y by x. I did that because they asked me to write in the form of y by x. Okay? They asked me write it as g of y by x. That's why. Next, I'm asking you to solve it by putting the substitutions for the type 1. Now answer log t equals log x plus log c. So that is log t is v squared plus 1 is equal to log cx. Now put back v, my dears. Y squared by x squared plus 1 is equal to cx. Beautiful question which you've done already, my dears. Okay, so it can be cx cube. Y squared plus x squared is equal to cx cube. The final answer is this, my dears. They didn't ask you to find any particular solution at all. So this 4 mark, 4 mark normally was old pattern differential equations where they asked you to show it's homogeneous and then solve it. This is a similar type of question. They made into 2 cases. First, showing it's homogeneous in the form of y by x and using suitable substitutions, solving the equation. I hope everybody is clear with this case-based question. So one more case came for us. So this case-based came in 2023. Okay. Now this next case came in 2024, my dears. A very, very important pattern. It's like a practical based question. It's showing the exponential growth of a bacteria in a given amount of time. And they are giving you the differential equation given by dp by dt is equal to kp. For such kind of practical questions, they will give you this differential equation form. And it will always be something like this. A very, very basic level. Okay, come on all of you. My differential equation is dp by dt. dp by dt is equal to kp. Now here k is called a proportionality constant, my dears. K is called what? A proportionality constant. Okay, and that p represents, P is the population of bacteria at any time t. Based on the above information, answer the following questions. Obtain the general solution and express it as an exponential function. Express it as an exponential function of t. General solution. It's a simple variable separable form. dp by p is equal to k dt. Okay. Now simply integrate both sides. It's not a complicated question, my dears. What is the integral of 1 by p? Log p. What is the integral of k dt? Kt plus the arbitrary constant c. I have been asked to express this in exponential form. This is a logarithmic form, not exponential. What is the inverse of log? All of you. Log y equals x implies y is equal to e raised to x. This is something that you need to know about the log and e functions. They're inverse of each other. So if you invert log to the other side, it will become e raised to the other side. So this is going to be what? T is equal to e raised to kt plus c. So I have expressed p in terms of exponential function of t and express it as exponential function of t. First question done. All of you, I am done with the first question. Now I am going for the second question, my dears. The second question is, they will give you some values. Obvious for these kind of questions, they will give you some values to find the arbitrary constant k and c. Both are there. First they said, the population of the bacteria is 1000 if t is equal to 0. If t equals to 0, p is equal to 1000. Put that over there. That implies 1000 is equal to e raised to 0 plus c. 1000 is equal to e raised to c. So e raised to c is 1000. That's it. Don't try to do too much. I got e raised to c as 1000. Next, what, my dears? Next, they are saying that 2000 if t is equal to 1. All of you, if t is equal to 1, p is equal to 2000. You substitute that again in this p. But before substituting, try to understand that p is e raised to kt into e raised to c. E raised to kt plus c. Exponential law. If x raised to a plus b is always x raised to a into x raised to b. Exponential law, my dears. X raised to a into x. The base is same. You add the powers. So, if you simply say e raised to kt plus c, it's e raised to kt into e raised to c. They are saying p is 2000, e raised to k into 1, t is 1, and e raised to c is 1000. So, we got 1000. Okay, that implies e raised to k is equal to 1000 and 2000 will cancel. You will get e raised to k is equal to 2. E raised to c is 1000, but e raised to k is 2, my dears. Very, very simple logic. Now, what are they asking? Find the value of k. Find the value of k. That implies k. I told you e inverse, it becomes log. K is equal to log 2. K is equal to log 2. I hope everybody understood the answer. This is two types of questions. One, trying to solve a normal differential equation. Maybe it is homogeneous, maybe it is linear. They will give the theory for that. You just solve it and give it back to them. A difficult question, maybe with few more steps than the normal 3-mark question. Second one, practical problem, my dears. Practical problem where they give you the differential equation in a very, very simple form, where you will always get two arbitrary constants k and c, and they will give you two set of values to find this k and c. So always remember this logic. The same logic is going to be followed for these kind of practical problems. I hope this discussion on the chapter of differential equation is clear to everyone, okay? This is a very, very important chapter for 5 marks for us in board exam. So please go through this video. I think it's more than enough to get that complete 5 mark in your hand. Though sample paper doesn't give you a 3-mark question or a case-based question in differential equations, don't be taken by that. This is not going to be the same pattern everywhere. Differential equation is a pretty important chapter. You can't say it's going to come only for 2 marks, so let me not study the 3-mark questions of differential equations or maybe the case-based questions, my dears. So everybody please focus and study the questions very well. So with this, I'm concluding the chapter for differential equations. Thank you. I'll come back with another chapter, my dears. Till then, bye.